Hello everyone, in today's video I shall discuss the GATE 2019 questions. In the previous video I have discussed till question number 14. Let's start. Question number 15 is a numerical problem, where the density, homogenization pressure is given. We are asked to find the viscosity of the flowing milk. This problem can be solved using Bernoulli's theorem, since Bernoulli's theory relates pressure head and velocity head for incompressible fluid. Since pressure loss is negligible, therefore, delta P is equal to P initial. Pressure is equal to the kinetic energy. Thus, V equals to root over twice P divided by rho. Substituting the value given, all in SI unit, we GE the value of velocity as 242.4 meter per second. The next question is a question of mass balance. First, let us assume that the total amount of potato is 100 kilograms. It is given that solid is 12%. So the amount of solid is 12 kilograms. From 12 kilograms, again 10%, amounting to 1.2 kilograms is removed during peeling. As the result, the solid part is reduced to 12 to 1.2 kilograms, which is 10.8 kilograms. Since the amount of solid doesn't change after drying, therefore as given 94% of chips is equal to 10.8 kilograms. Thus, total chips is equal to 11.49 kilograms. Since yield has to found in percentage from original mass, so 11.49 divided by 100 kilograms initial potato is equal to 11.49%. From given data, one has to calculate the mass flow rate of steam. The first step is to convert beverage flow rate to kilogram per second. Mass flow rate equals volumetric flow rate multiplied with density. Heat required to heat the beverage is mass into specific heat into temperature change. The energy supplied by steam is equal to the heat required for latent heat. Equating the heat energy, we can equate and calculate the mass flow rate of steam in meter per second. The Nusselt number, Nu, is indeed a dimensionless quantity that characterizes convective heat transfer. It is related to both the Reynolds number, Re, and the Prandtl number, Pr, as well as the geometry of the system and the flow regime, laminar, transitional, or turbulent. The relationship between these numbers helps describe the convective heat transfer process. Thus, convective heat transfer coefficient is calculated from the Nusselt's numbers value. From the given values, we first have to calculate the partial pressure of water vapor. That can be done by relative humidity is the ratio of the actual water vapor pressure to the saturated vapor pressure, PV. After calculating PV, PA is calculated. The total atmospheric pressure is the sum of the partial pressures of dry air and vapor pressure. Thus, PA is 96.9 kilopascal. Then calculate the specific humidity using this formula. Calculate the virtual temperature, which is TV. The virtual temperature accounts for the effect of humidity on the density of air. After temperature, using ideal gas law, the volume of humid air per kilogram of dry air and is given in this equation. The porosity of the flakes is 60%, meaning that 60% of the bed volume is void space. The solvent will only flow through this void space. Therefore, the effective velocity of the solvent is equal to belt speed divided by porosity. Residence time is the time the flakes spend in the extractor. The bed depth and the belt speed determine this. The distance d the solvent travels is equal to effective velocity multiplied by the residence time. Thus the final answer is 125 in centimeters. Given are the values of parameter for the moisture, water vapor transmission rate, thickness, and speed. We need to find the distance between the washing nozzle and the micellar collecting receptacle. First, let us understand the water vapor transmission rate. It represents the amount of water vapor that passes through 1 square meter of the barrier film per day. By linking water activity to moisture content, the isotherm helps identify the critical moisture content. First, calculate change in moisture content. Then water vapor transmission rate in SI unit. After that, change in water activity using the slope of the sorption isotherm. Last, the equation for time T divides the moisture required by effective water transfer rate. Pause the video to look at the explanation of this topic. Last question is on freezing time. Similar question has been discussed in previous video. The only different explanation is the calculation of latent heat is slightly the tricks, since it has been mentioned latent of fusion is for 60% of moisture. Therefore, latent heats needs to calculate by multiplying it with 60%. Ignore the initial freezing temperature because in this equation only temperature of the food and temperature of the ambient fluid is required. The rest is the same. Remember the Planck equation. A question usually comes from this. Remember the different values of P and R for different geometry. Just need to do stepwise calculates and find the time. These are the reference website for the given solutions. Thank you for watching. Watch the playlist for more PYQs of GATE food technology.